Hi, and welcome back to LFI Educates. Today, we will be learning on the first unit of chemistry, that is, state of matter. To live, constantly we are using substances in different physical states around us. Can we give them a name collectively? You may be surprised, but the answer is yes. They are called different forms of matter. What is matter? Matter is anything that has mass and occupies space. For example, bricks, water, and air. Matter are sorted into three groups. These groups are called solid, liquid, and gas. All three forms of matter is made up of very small particles which exist independently. Solid, liquid, and gas have different properties. Properties of solid. Solids keep the same shape, they take up the same amount of space, they keep the same volume, and they cannot be poured or compressed. Properties of liquid. Liquid take the shape of the container they are in. Liquid can be poured and can move through gaps. They cannot be squashed. They take up the same amount of space and they keep the same volume. Properties of gases. Gas flow like liquids. They are very easy to squash or compress. The volume of a gas can change and gas weigh very little. Next, we have particle theory. In solid, there are strong forces of attraction which holds the particles close together in a fixed position and it have a definite shape and volume. The particles can only vibrate around them. This means that solid cannot flow. In liquid, there are weak forces of attraction between the particles, so they are free to move around and are arranged pretty randomly. However, the weak forces of attraction do mean that the particles stick together and are fairly compact. This also means that they have definite volume and even shape can change, allowing them to flow and fit in a container. In gases, the force of attraction between the particles is very weak, so they are basically free to move around by themselves. It means the gases don't keep a definite shape or volume and instead will always fill a container as to spread out as much as possible. The next subtopic is changing state and explaining changes of state. Have you ever wondered why ice turns into puddles of water on a sweltering day? Do you know the difference between evaporation and boiling? Both are when the substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gases. Water standing in a pan that has not been heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles on the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slow process than boiling, and both are types of vaporization. The opposite of vaporization process is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day. Those water droplets on the outside or the dew on the grass in the morning, even the clouds in the sky. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now, let's think about transition between solids and liquids. So, melting and freezing. Think of the Arctic sea ice in the summer when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice and water molecules, and the ice starts to melt. The solid ice becomes liquid water. This is because the particles vibrate so much that some escape the strong forces and can move around as a liquid. But in the winter, the air temperature are colder and so seawater freezes and the ice starts to form again. There is less heat energy within the ice and so more bonds can form, holding it together as solid ice. Measuring volume. When you measure the volume of a liquid, you use a measuring cylinder. The liquid forms a curve at the top. This is called meniscus. Measuring temperature. To measure temperature, we use the thermometer. The liquid present inside the thermometer is called mercury, and it expands as it gets hotter. Well, there you have it, states of matter. Thank you.